In this second lesson of Calculus 3, we're going to be talking about parametric functions or parametric equations. These are used when you want multiple dimensions to be dependent on a single variable. Here's an example of a function that is x and y are both dependent on the variable t. For this specific function that I've drawn, x is equal to t and y of t is equal to 3 plus 2 cosine t. If we were to draw the vector r of t going from the origin to the leftmost point on the graph, we would substitute in t for x of t and 3 plus 2 cosine t for y of t. When t is negative 4, x of t would be negative 4 and y of t would be 1.7. If we were to vary t from negative 4 to positive 4, we would trace out the yellow line on the graph as is being shown right now. This is the main use of parametric functions, being able to change one variable, one input, and affect two variables or two outputs, in this case x of t and y of t. Moving on to the three-dimensional view, we are now going to look at three forms of how to represent a line using parametric equations. The first is the vector form of a line. First, we are going to take an initial point on the line, p naught. It's going to have the coordinates x naught, y naught, and z naught. Then we are going to take an arbitrary point on the line, p. It is going to have coordinates x, y, and z. These points are going to become the endpoint of our vectors, r naught and r, going from the origin to those given points. From the last lesson, we know that there exists a vector so that r equals r naught plus that vector. We're going to use the vector name u, where r equals r naught plus u. Now, how do we solve for u? Well, u is going to be equal to a slope in the x direction, a slope in the y direction, and a slope in the z direction times our parameter t. When we add these two together or substitute them in, r equals our initial point plus our slope in each direction times t. This would be the vector form of a line, and you would use this if you're given a point plus a slope or a direction vector. If you were to plug in a value for t for this form of the line, it would give you the position vector r from the origin to the point you're interested in. Moving on to the second form, the parametric form of a line. This form is derived by taking the vector form of the line and breaking it up into its x, y, or z direction. You can see that each individual direction behaves like a 2D line. Y equals mx plus b, or in this case, y equals bt plus y naught. If you were to pick a value for t in this form, you would be given the actual coordinates of the point on the line. So for example, in this case, this would be point P. These are what is known as the parametric equations of a line. Finally, we have our third form, the symmetric form of a line. This is derived by solving for t for each of the three forms of the parametric equation and setting them equal to each other, because each equation will equal to t. You can use this to solve for a, b, or c without the presence of t if you don't want to plug in a value. Additionally, if a, b, or c is equal to 0, then you need to drop that from this equation, because that would cause to be division by 0, which would be undefined. What that means for the problem is that if a is equal to 0, that means that x is no longer a function of t, and x would just equal x naught, for example. Finally, I'm going to show you a simple 3D parametric function. It's going to be a function x of t, y of t, and z of t. This function is going to be x equals cosine, y equals sine, and z equals t over 10. If you draw out this function, it's going to be a spiral oriented around the z-axis. If we were to vary our t value from the minimum of the spiral to the maximum of the spiral, you'll see that changing one variable, t, alters 3 different dimensions, x, y, and t. You can watch the animation again to get a better understanding of what was going on there. Finishing up today's lesson, we learned about 3 different equations for a line: the vector form of a line, the parametric form of a line, and finally the symmetric form of a line. These 3 equations are used in different situations depending on what you want to do, which we outlined in the video. If this video helped you with understanding parameterization of a line, give it a thumbs up and subscribe to Learnometrics for more Calculus 3 content. I'll see you again soon with another video.